Good morning, students.
Good morning, sir.
I welcome you all in my today's class. As you know, we are studying electricity and we have studied previously electrical resistance and the factors affecting electrical resistance. And we have also studied Ohm's law, right?
Yes, sir.
Now today we'll just study how to connect different resistors when you are having more than one resistors. And for that, you need to connect them all. So we have got many ways to connect them so that we can get the different amounts of resistances. So the ways of connecting resistors are, first one is series combination. It's also called as resistors in series or series combination of resistors. Then the second one is parallel combination or resistors in parallel. The third one is mixed, where you are having a circuit where you get both series as well as parallel resistors, right?
Yes, sir.
In today's class, we'll study about the series combination. Okay. So resistors in series. Now, first of all, we'll study how resistors are connected when they are to be connected in series, right? So, the first thing about the series combination is the resistors here are connected end to end. This is also called as end-to-end combination of resistors, end-to-end connection of resistors. So what is that? In this combination, we connect, say for example, we are having three resistors, say R1, R2 and R3. So I'll connect three resistors. This is the R1, the two ends of the R1. The first end of the first resistor is connected to the first end of the second resistor. Then the second end of second resistor is connected to the first end of one end of third resistor. Then the free ends, this is R3, this is R1, this is R2 and this is R3. The free ends, this is the free end of first resistor, this is the free end of last resistor. So the one end of first resistor is connected to the one end of the second resistor. The second end of second resistor is connected to the one end of the third resistor, and so on. I can have the fourth one, I can have the fifth one. The free ends of the resistors. Which resistors? The first one and the last one. The free ends of the resistors are connected to the two terminals of the battery through a key. I can connect an ammeter here also, which will measure the current. So once I switch on the circuit, the current will flow along this, passes through this, crosses this resistor first, then second, then third, and completes its circuit. So the first point about series combination is end-to-end connections. That you understood?
Yes, sir.
The second point about the series combination is, during series combination, the current through each resistor remains same. If the I amount of current flows, the current I will flow through this resistor, it will also flow through this resistor, it will also flow, the same amount of current will flow through R3. Then the charge will complete its circuit. Okay?
Yes,
Done?
sir.
The second point about this series combination is the total potential difference I apply here. It will get divided. It will get among the individual resistors. It will get the total amount of potential difference applied will get divided among the individual resistors. So I will divide it. The potential difference across the first resistor is, say for example, V1. The potential difference developed across the second resistor is V2. The amount of potential that R3 gets is V3. You got it?
Yes,
so 2 points I will discuss again. The first point is, during series combination, the total amount of current through each resistor remains same, but the total potential difference gets divided among individual resistors. Till now, tell me, do you have any questions?
Yes, sir.
Yeah?
Sir, how can current be same through all resistors? It should decrease after facing a resistance.
Okay, good question. See, here the current is because of flow of charge. That you know, the rate of flow of charge is called as, if certain amount of charge starts from here, that flows from here, or actually the electronic current in metals, the charges flow from along negative terminal. They go negative to positive. But conventional current starts from positive to, it goes from positive to negative. So the amount of charge starting from here has to reach here. Got it?
Yes, sir.
Then that will contribute to the electric current. The amount of charge which starts from this terminal and reaches to this terminal, that will only contribute to this electric current. Okay?
Yes, sir.
So for that reason, the total charge has to pass through this barrier, and this barrier. Now the question is how the barrier is crossed. How this task of crossing this barrier is accomplished. It's only, we have applied potential difference, the charges will come out and they will cross this barrier by getting the energy from this external source, that is battery or whichever source you have placed there. Is it okay?
Yes,
मैं फिर से बोल सकता हूं आपको कि यहां पर क्या हो सकता है. Have you seen race? I mean to say athletes running.
yes, sir.
जब एक एथलीट दौड़ता है उसको अब हम उसी को विनर मानते हैं जो लाइन क्रॉस करता है, राइट? जो रास्ते में रुक जाएगा उसका वो रेस से बाहर हो जाता है. क्लियर? तो इसी तरह से यहां पर भी while just रनिंग एथलीट को एनर्जी की जरूरत पड़ती है, राइट? तो उस टाइम पे इफ वी पुट हर्डल्स इन फ्रंट ऑफ हिम, तो उसको वो हर्डल क्रॉस करना है, राइट? तो उस हर्डल को क्रॉस करने के लिए उसको एक्स्ट्रा अमाउंट ऑफ एनर्जी की जरूरत पड़ेगी. टू क्रॉस दीज बैरियर्स ऑफ रेजिस्टेंस, द चार्जेस विल रिक्वायर सम अमाउंट ऑफ एनर्जी, सो दे विल गेट दैट एनर्जी फ्रॉम द बैटरी, फ्रॉम द सोर्स. After getting that energy, they will cross each and every barrier. So that means whatever amount of charge will come out from this end, that has to reach to this end. That will reach, and that will then contribute to electric current. You got it?
Yes,
That will
sir.
then contribute to electric current. You got it? So, in this way, the amount of charge crossing through R1, R2, and R3 will remain same. So, in this way, the current through each resistor remains same, but the potential difference gets divided among the individual resistors. Is it okay now?
Yes, sir.
Now, after that, you can see the circuit here, circuit diagram, another circuit diagram. This is the battery, ammeter, switch, key. Then this is R1, R2, and R3. This is the this is voltmeter. It will measure the potential difference across the ends of this resistor. Okay, and the ammeter will measure the total amount of current that flows in the circuit. Clear? Now you can see. We'll try to derive the equation for equivalent resistance. So after connecting this R1, R2, and R3, let me say the total resistance becomes, say, R. R equivalent. That is called as equivalent resistance. The combination of the three resistors. That's called as total resistance in series or equivalent resistance. Now, this is the total resistance R, and total current is I, and the total potential difference is V. Now you know, I told you earlier, during parallel combination, the total potential difference gets divided among the individual resistors. That means the total potential difference is V. This V will be equal to, that's divided here, V1 plus V2 plus V3. Clear? Let me say this is equation first. This is equation first. Yes, this is the equation, right? The total potential difference is the sum of the potential difference across each resistor. Then, now, do you know Ohm's law? You know Ohm's law? What is Ohm's law? The equation for Ohm's law is V is equal to I R. Clear?
Yes, sir.
Now tell me, this is the total potential difference of the circuit. This is the total current of the circuit. And this is the total resistance of the circuit. So by using Ohm's law,
Ohm's law.
can I say this total potential difference is equal to total current into total resistance, that's R equivalent, okay, is equal to this V1 for this resistor. If I apply Ohm's law for this particular resistor, if I apply Ohm's law, that is V1 is equal to IR1 plus V2 is equal to IR2, very good, plus IR. Is it clear?
Yes, sir.
Clear? So here, this is equation second. I can open it. I can put this, we can go for V1 separately, that V1 is equal to IR1, then V2 is equal to IR2, then V3 is equal to IR3. So, the overall equation becomes IR, that is this equal to total potential difference. Then V1 is equal to IR1 plus IR2 plus IR3. So I have substituted the values of V1, V1, V2 and V3 in this particular equation, right? In equation first. You got it?
Yes, sir.
Then you can see here V1 is equal to IR by using Ohm's law. V, total potential difference of the circuit, that is V, is equal to IR. Similarly for V1, IR1 for V2. Similarly for V3, IR3. And we will substitute the values of V1, V2, V3 from equation, say for example, second, third, fourth and fifth in equation first in this particular equation. So we'll get finally IR equivalent is equal to IR1 plus IR2 plus IR3. Then, can you see this equation? What is common in it? In this. So can I write here IR equivalent is equal to I into R1 plus R2 plus R3. I will take I out because that's common in all the three, right? Then in both sides of the equation I have got I and I same, so they'll get cancelled out. Okay? So finally tell me R equivalent is equal to?
R1 plus R2 plus R3.
So this is the final equation. This is the now I was having only 3 resistors. The equation became total resistance R equivalent is equal to R1 plus R2 plus. If I have got the 4th resistor, then that will be plus. If I have the n number of resistors, the final equation will become. If I have, say for example, 4 resistors. R1 plus R2 plus R3 plus dash 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 plus Rn. Got it?
Yes, sir.
Any confusions?
No, sir.
Okay. Say for example, we can solve a question here. Say, see, an electric lamp whose resistance is 20 ohm, then and a conductor of 4 ohm resistance are connected in series to have 6-volt battery. To a 6-volt battery, calculate the total resistance. Can you calculate it now? You are given with 20 ohm resistance is connected in series with 4 ohm resistance. So which formula you will apply? Can you apply now this formula? See. You've got 3 resistors now, 2 resistors now. R1 here it is given 20 ohm, then R2 here is given, that is 4 ohm. Calculate the equivalent resistance by applying the formula of series combination. Can you?
Yes, sir.
See how we'll do it. You know R equivalent is equal to R1 plus R2. So R equivalent is equal to 20 ohm plus 4 ohm. So the total will be 24 ohm. It's like this. Is it tough?
No, sir.
Now, do you have any questions?
Yes, sir.
Yes.
Sir, what is the equivalent resistance when three resistors, 10 ohm, 20 ohm, and 30 ohm, are connected in series?
Let me solve it. Just repeat the question. Yes?
Yes.
Ah.
Sir, what is the equivalent resistance when three resistors, 10 ohm, 20 ohm, and 30 ohm, are connected
See,
in
whenever
series?
you get a numerical, do one thing first, make it circuit diagram. So you are having three resistors. This is the R1, then this is R2, and this is R3. And you have connected them in series. Okay?
Yes, sir.
So R1 is equal to how much? 10 ohm.
Yes.
Then R2, 20 ohm. Then R3, 30 ohm. It is simple. It's very easy. You need to apply the formula of series combination. That is, in this equation, R1 is given, R2 is given, and R3 is given. If I'll substitute the values of R1, R2, and R3, R equivalent, you know, is equal to R1 plus R2 plus, that means 10 ohm plus 20 ohm plus 30 ohm. So this will be, the sum will be 60 ohm. Anything else?
Yes.
Do you have any other question?
Yes, sir. My question is that if in same circuit the potential difference is 120 volts, then what will be the current?
In the same circuit?
Yes, sir.
Okay, that means you are applying now in the same circuit, you are applying, say, the potential difference how much? 120 volt. That means V is now given. This question is related to the Ohm's law. So, R equivalent is already given. Then you are putting, see, what is given to you now? This is R equivalent is given, then V is given. V is how much? 120 volt. That means we know, we need to find what? Current. We know. What we know? Oh, by applying Ohm's law, V is equal to IR. That means I is equal to V by R. That means I is equal to 120 volt divided by 60 ohm. So that is 60 ones are 62 are. I will be simply 2 ampere. Is it okay?
Yes, sir.
So we are having another question here using the previous data. This 24 ohm, calculate the current flowing through the circuit if the potential difference. It's the same question. It's just like this. So 24, that means 6 divided by 24. The current will be equal to V divided by R. So if I just get a whole summary of this lecture, we discussed the series combination of resistors, right? So first of all, I told you during series combination, the resistors are connected end to end. So what is the meaning of this end to end connection? One end of first resistor is connected to the one end of second resistor, and the second end of second resistor is connected to the one end of third resistor, and the second and so on. If you can have the fourth one, you can have the fifth one, and so on. You can have n number of resistors. Exactly. So after that, we discussed during series combination, the first point, end-to-end connections. Now what happens to the current when the resistors are in series? Current through each resistor remains same. I hope that's clear to you.
Yes, sir.
Current through each resistor remains same. If you see the parallel combination, there happens the reverse. The reverse thing happens there in case of parallel combination. The current gets divided and the potential difference across each resistor remains same. That is in the parallel combination. That we'll see in the next lecture. But in today's lecture, it is series combination. So, what happens to the potential difference in case of series combination? During series combination, the total potential difference applied gets divided among individual resistances. And the third point is resistances is equal to the equivalent resistance. So in short, we can say if you are supposed to get the value of equivalent resistance in series combination, how will get it? So I can make a point here, I can make a point which is related to the higher competitive exams, which will help you. That's a shortcut basically. So the first thing is, during series combination, the total resistance is equal to the summation of individual resistances. Is it so? During series combination, the total resistance is equal to, or equivalent resistance is equal to, summation of individual resistances. Now there's a simple thing to understand how to solve the questions related to this in less time. Sometimes you get a question where you need to spend very less time. Say for example, there are 3 resistors given to you. The first one, second one, and the third one. See how you'll just solve it in less time. The R1 is, say for example, R1 is 2 ohm. R3 is, say R2 is 3 ohm. Then R3 is, say 4 ohm. So you will just do one thing, you will make their sum. That's equal to equivalent resistance. But there is one more point, that how I get out. You will just see the options. See if the options are given to you. The first option, option A, is, say for example, 2.5 ohm. Option B is, say for example, 3.5 ohm. Option C is 4 ohm. And option D is 9 ohm. Okay?
Yes.
So we know, if I add them, we always get the value larger than the largest possible value. 2 plus 3 plus 4, when I add them, what I will get? That is larger than the highest possible resistor. So in series combination, see which one is having the highest value. Say here it is 4 ohm. The answer will be always larger than this. So 3 options, I got 3 options which are smaller or equal to the 4 ohm. So I will cancel all the 3 and I will select this one. Sometimes you may be given, आपको कभी क्या होगा, एक क्वेश्चन में आपको से ये तो सिंपल वाला था, कभी डेसिमल, कभी फ्रैक्शंस में आता है, कभी कोई लार्जर जिसमें बहुत सारे वैल्यूज होते हैं. That time how you will solve that? You will see the largest given value of resistance. Say for example, here it is 4 ohm. Answer will be always larger than this. So you will cancel all those options which are less than this or equal to this. Which are less than this, or 2.5 was less than 4, 3.5 was less than 4, 4 was equal to 4. So we left with
9.
So the answer will be, without seeing them, you cancel them and the correct option will be this. Now the question is, sir, sometimes there may be 2 values which are larger than the 4.
Yes.
That times you will cancel those 2 which are smaller or equal to the 4. Okay? You will just, then you will calculate the, sometimes you don't know. So that time you will just see only those 2 options. So you'll get the probability. Probability will increase. Okay?
Yes.
I think this is all understood now.
Yes, sir.
Is there any questions?
No, sir.
Any confusions?
No, sir.
Are you okay with this?
Yes, sir.
So in next lecture, we'll go for the resistors in parallel combination. We'll go for the parallel combination, that is resistors in parallel. Okay?
Yes, sir.
Thank you very much.